This conference will now be recorded.
Right, let's start today's session. In the last session, we were discussing about single inheritance, multi-level inheritance, and then hierarchical inheritance. And today we'll look into multiple inheritance and hybrid inheritance. Okay, and at the same time, what is the constructor role in inheritance concept we'll discuss. So first we look into multiple inheritance. In general, in other programming languages like C#, .NET, Java, multiple inheritance is not possible. With the help of interface only, multiple inheritance is possible. But in Python, multiple inheritance is completely possible. So multiple inheritance is the process of creating new class from two or more base classes. Yes, multiple inheritance is the process of creating new class from two or more base classes like this. Two or more base classes. It is multiple inheritance. So in Python, multiple inheritance implemented using MRO technique, method resolution order. This is multiple inheritance exactly. Diagrammatic representation. Now, I'm just creating new class from two more base classes here, two or more base classes. Here, we can call it as this is class A, and here it is class B, and class C here it is. Class C is inherited from A and B. Multiple inheritance implemented using MRO technique, that is method resolution order. Method resolution order. Method resolution order, MRO. This order is always clockwise. Now you can see this is, and here this is. And now you can see here it is. That means in class A, if class B are having both are same function, in that case, first priority will give to class A. In that case, left hand side, whatever this class A is there, left side, okay. In class A, if there is no function, then next priority immediately will give to class B only. Both classes are having same function. Class A function will give priority first. If that function is not present in class A, then next priority will give to class B only. First, let's try to look into the example first. Test 16 I'm taking here. Now in this case, just observe here. I'm preparing this two classes, class A, class A. Class name is A. In this class, I'm creating one function called F1. Printer F1 function of class A. Okay. Next, class B I'm taking at base level, one more class B. F2 function I'm taking. Print F2 function of class B. F2 function of class B. So class A, class B, df F1 function of class A, class B, df F2 function of class B. So class C class is inherited from where? A and B. So this is multiple inheritance. C inherited from AB. Diagrammatically, you can see C is inherited are derived from A and B. A and B are parent class of C. So here C class can have right to access A class functions as well as B class functions because both are the parents of C only. So compulsory you have to access F1 and F2 functions in C class directly. Okay. And if it has C class is having its own functionality, it's okay, no problem. That also can implement. Print F3 function of class C. This is. Now we should create object for which class? Generally child class. Okay, you can also create object for parent classes, but if you create object for parent classes, you can access parent functionality but not child functionality. In inheritance, if we create object for child class, then we can access parent class functionality also because child class object we can access parent class functionality. So here C is the child class which is inherited from its parent A and B. So I'm going to create object for C class. C is the object name, small c. Capital C is the class name. And C dot F1 I'm taking. So F1 function is coming from where? A class. You can see A class. It is coming from A only. Clearly it is saying intelligence. C dot F2 function I'm taking. F2 function is coming from where? B. C dot F3 function coming from where? C. C dot F3 means F3 function is coming from C only because implemented in C. This is very clear. There is no complex. Okay. So we created three classes. In that C was inherited from A and B. F1 function of class A, F2 function of class B, F3 function of class C. I can see this is okay. Yeah. Now observe here. In base level, A class and B class are having same function. A class and B class are having different function F1 and F2. So we can easily access F1, F2, and F3. What happen if base classes both are having same F1 function only? Just observe here. This function name is same and this function name is same. F1 function of class A and here also F1 function of class B, sir. Okay. Both base level, these are having same function or not? Like here F1 function is there. F1 function. Here also F1 function is there. B class also is having F1 function. So in this situation, according to method resolution order, first priority goes to A class. In case this F1 function is not present in A class, then next priority will go to B class only. Got my point? So right now you can see both are having F1, F1, class A, class B. Now below you can see this whenever I try to F2, F2 is not there, you can delete it. But you just observe here, when we try to call C dot F1 function, so F1 is coming from where? F1 is coming from where? A. So this A class, the C dot F1 of A. So why A only, sir? Why not B? Because priority. So here what order you mentioned? A comma B. That's what priority goes to A only here. Same according to diagram. A, first priority A. Now let's run this. F1 function of class A and F3 function of class C. So we are missing what? F1 function of class B only. Okay. Yeah. Just notice this. Next, let me change the order, sir, here. A comma B not. I'm just giving B comma A. So whenever we try to access here C dot F1, you can observe in IntelliSense, F1 is coming from where? B. The reason is what? We mentioned first B only. That's what it is coming. First priority will give to B. But in the diagram, it doesn't mean that here right to left. No, we changed this class B, no? So that's what F1 is B only. Then A here, F1 of later A. In case here F1 function is not available, we changed here in place of A, B, we changed in the coding part. So B comma A, this order is important. So basically we are getting F1 function of class B only, priority is like this. F1 function of class B, F3 function of class C here. F1 function of class B, F3 function of class C only. Okay, F3 function of class C only. F1 function of class B, F3 function of class C like this. This is the case. Okay, yeah. Sir, what happened? Can't we get a F1 function A and F1 function B? Both are not? Yes, possible. Let's show you. So here A comma B I'm taking. Obviously, priority will give to A class F1 function only. So once I run this, A class F1 function is coming. But if you want to access B class function also, then what is happening, B class function also if you want to get, then there is a possibility is there, I'll tell you. But in case first, if I don't have F1 function, sir, in case in class A, there is no F1 function, sir. In class A, there is no F1 function. Then first priority will give to F1 of class A only. If there is no F1 function in class A, then obviously priority will be changed. Next priority will go to class B only. So here I have not included any F1 function in class A. First it will look forward A class F1 function. If not there, then immediately it will search for B class F1 function. If it is there, then B class F1 function will call. F1 function of class B, F3 function of class C. But here I need both class F1 functions are A class F1 function and B class F1 function. So here I have included A class F1 function. Obviously the priority will go to A class F1 function only. C dot F1 means you can see C dot F1, A class F1 function only. Okay, C dot F1. Okay. But next we are missing B class F1 function. In that case, if you want to use this F1 function of class B also, how it is possible means inside the derived class, this is C class, derived class, F3 function, we have to call B is the class name dot F1 of self. B is the class name dot F1 of self, because we are getting priority A class F1 function. Obviously, we will miss the B class F1 function. So if you don't want to miss B class F1 function, there is a possibility in the derived class inside the F3 function, we can use class name dot F1 of self. So obviously you will get B class F1 function also. F1 function of class A, F1 function of class B, F3 function of class C. In case if your order is look like B comma A, B comma A, your order is B comma A. So B comma A in the sense, first priority will give to B. Obviously you will miss what actually? Let me comment this. Obviously you will miss what? A class F1 function we will miss. F1 function of class B is coming, but A class F1 function we are missing. A class F1 function, if you want to get again, what you have to use? Here we have to use A class name dot F1 of self. Once I run this, now you can say A class name dot F1 of self. F1 function of class B, F1 function of class A, F3 function of class C like this. Okay. So this is what B comma A we are giving. That's what A missing A dot F1 also it is coming. So this is multiple inheritance, means creating new class from two or more base classes is called multiple inheritance. In Python programming, multiple inheritance is possible. Okay, with the help of method resolution order. This is actually technique or algorithm, we can call it as. Using this MRO algorithm through the multiple method resolution order is completely implemented. Method resolution order, MRO technique, we can say that method resolution order here. Okay, let's go to here. Next, hybrid inheritance is there. Hybrid inheritance is the combination of multiple. Let me show you. Hybrid inheritance is the combination. This is only Hybrid inheritance is the combination of multiple and hierarchical and multi-level, all these things. Now this is hybrid inheritance, we can say that. This is class D. Class D. D is inherited from a C only. So it is the combination of multiple as well as multi-level also. So A, C, D is multi-level. B, C, D is multi-level. A, B, C is multiple. A, B, D is multiple, like this. Let's include one more class here. I'm creating one more class. Let's remove this one. Extension I'm doing. Class D of C. D class is inherited from C only. In this C class, I'm creating one more function called F4. Print what I can say, F4 function of class D. F4 function of what actually? Class D I'm taking. F4 function of class D, like this. Now we should create object for obviously what's our D class. D equals to D. D dot F1. D dot F3. It is coming from C. D dot F4. So whenever we got D dot F1, obviously it is coming from B class. A class is missing. A class already be included here because of F3 function. So all the functionality we will get clearly. F1 function of class B, F1 function of class A, F3 function of class C, F4 function of class D here. So this is what we have clearly. F1 function of class B, F1 function of class A, F3 function of class C, F4 function of class D, like this. Okay. This is multiple inheritance, single inheritance, hybrid inheritance, multi-level inheritance combination. But in this case, I need to discuss about constructor role in inheritance, sir. Constructor role in inheritance. In every class, I included method, but I have not included any constructor. If you have a constructor, okay, in each and every inheritance, how it will be? Okay, constructor role in inheritance. Constructor role in inheritance. All the inheritance I'll explain. Constructor role. Constructor role. Constructor role in single inheritance. Constructor role in multiple inheritance. Constructor role in multi-level inheritance. All the inheritances. First, we look into constructor role in single inheritance. Constructor role in single inheritance. Constructor role. I'm taking class A. Here I have constructor is there. Print A class constructor. A class constructor. Next I'm taking class B. Df underscore underscore init. Print B class constructor. B class constructor here. Class A. So this is initialization constructor. It is A class constructor, class B, B class constructor. But one thing is for sure, these two classes are individual classes. There is no inheritance related with them. Obviously, when we create object to the class, what will happen here? B equals to B, and this class is going to be inherited. So once I run this, now you can see this B class constructor clear. B class constructor is coming. Yes, obviously, when we create object to the class, as soon as when we create object to the class, what will execute? Constructor will execute. You know that. Suppose if there is no constructor is involved in B, then what will happen? Nothing will happen. So there is no constructor in B, so constructor will not execute. So we just create object. It look like it looking forward to have the constructor in B, but unfortunately there is no constructor in B. There is no output here. So for example, in this case, if I include inheritance symbol. Inheritance symbol in the sense B is inherited from A. Again, I'm including constructor here. Include constructor here. So B class inherited from A. So we create object for B class. Obviously, B class constructor will execute. So once I start run this, now you can see B class constructor is executing or yes, B class constructor executed here. B class constructor executed. If there is no constructor in B class, there is no constructor in B class. Now coming to this, obviously priority will give to what? A class only. The reason is this class and this class inherited with each other. So B is inherited from A. If the relevant constructor is not present in B class, immediately priority it's go to parent. So this is available here. So constructor role in single inheritance is this one. And at the same time, constructor role in multi-level inheritance. Suppose class C inherited from B and df underscore underscore init. Print class C class constructor here. Print. Now you can see C class constructor. C class constructor. C class constructor. So this is here I'm including. Here I'm including A class. B is inherited from A. C is inherited from B. Now you can see C equals to C. C class constructor, yes. We just create object for C class. That's what constructor is involved. In case there is no constructor present in C, obviously the next priority will give to its parent. What is C parent? B. In case B also don't have constructor here, now you can see B class. Obviously priority is what? A class constructor. So A class constructor. B is inherited from A, no? So when we try to hit this object for B, B class don't have constructor, then immediately priority goes to A only here, clear. So this is what constructor priority, constructor role in multi-level inheritance. Even then hybrid inheritance also. Sorry, multi-level inheritance, multiple. Even then in multiple inheritance also same. Let's edit this. B class is having constructor. A class also is having constructor. And now you can see C is inherited from A and B. Just observe here, A and B. C inherited from A and B. And once I use this, now you can see so C class object I created, obviously C class constructor will execute. And if there is no constructor present in C class, now obviously priority goes to what, sir? The order is what? A comma B. So first priority will go to A because order you can observe here. A comma B is there. So first priority according to method resolution order, A class constructor priority. If there is no constructor present in A also, the next priority will give to what? B class constructor. B class constructor here. Okay, B class constructor. Okay. So this is constructor role in multiple inheritance. Even then hybrid inheritance also same. Inheritance advantage means if you have a base class or parent classes or child classes implementation directly we can reuse into parent class implementation directly we can reuse into child classes. That is the main advantage of inheritance. Next I'm taking class D. D is inherited from C. Df underscore underscore init and print B class constructor. B class constructor like this. So we can create object for D equals to D. So when we create object for D class constructor only will be initialized. If this is D class, name is wrong. D class constructor only will be initialized. Now we can see D class constructor initialization. If there is no constructor present in D class, obviously C class constructor will be initialized. Now C class constructor, I am taking initialization part. C class constructor, yes. If there is no constructor present in C class, then obviously which class constructor? A class only, because A comma B, no, A priority will give. Even A also not there, then last finally B class. So this is overall complete inheritance process, constructor role and method role, everything here. Main advantage is parent classes or base classes, whatever implementation you have, that implementation we can able to reuse into child classes. This is inheritance topic, reusability and extensibility in Python. You can implement any logic in that. Okay. Next, that is third feature is there. One more feature, that is polymorphism feature. Features of object-oriented programming is what? Encapsulation, inheritance, polymorphism, then abstraction. Now coming to the polymorphism. In polymorphism, this is the third feature. In polymorphism, poly means many. Poly means what actually? Many. And morph means what actually? M-O-R, M-O-R-P-H. Morph means, poly means many and morph means behavior or forms. Many forms or many different behavior. In object-oriented programming, if we take any operator, that is plus operator or star operator, whatever it is, or function, add function, subtract function, or any function, it will show different behavior depends on situation. In object-oriented programming, if we take any function or parameter, it will show different behavior when we change data types of arguments to the function or when we assign different tasks to the operators. Suppose we can consider plus is operator. It is used to add two numbers and also it is used to add two strings. So when it is trying to add two integers, two numbers, behavior is different. When it is trying to add two floating values, behavior is different, like this. So same, you can consider any function. Function is having two parameters, behavior is different. Function is having three parameters, behavior is different. So that is polymorphism nature of the function or operator. And polymorphism can be of two types. One is a static polymorphism, static or compile time, we can say that, compile time. Next one is dynamic polymorphism or runtime polymorphism, runtime. So this static polymorphism is related to overloading concept, overloading. Dynamic polymorphism is related to overriding concept. Overloading means what? Suppose as a person, if we have already some work to do, as a person, if we have already some work to do, again, if you have some other work to do, other work also you have, suppose, means you should do multiple tasks, no? So at that time, you will become overload because extra tasks you are going to do along with existing tasks. This is overloading. A person can do multiple tasks one by one and keep on doing. That is called overloading. In Python programming also, if a function is having multiple tasks one by one, then that is overloading of the function only. Overriding means replacement, means in place of existing task, we are trying to do new task. That is called replacement. Overriding is the concept called replacement only. So overloading, overriding, these two undercomes into polymorphism. Overloading is always refinement technique. Refinement. Refinement technique means every time we have to change the things at the time of program compilation. Means before execution, you have to do changes. That is refinement technique. Overriding is always replacement technique. Replacement technique means replacement technique means at the time of program execution, existing task can be replaced with a new task. Existing task can be replaced with a new task. Means replacement. Instead of old one, new task will be prepared. That is called replacement. This is happen. Overriding is going to happen at program execution time. That's what it is. Dynamic polymorphism means runtime polymorphism. And the overloading is going to happen before execution. That is compilation time. That's what we can call it as static or compile time polymorphism, like that. Okay. So this is polymorphism. First, we look into overloading, and then after overriding. But first of all, I have to check. We have to discuss whether Python support overloading or not. If not support, then what type of overloading not support, what type of overloading support, we'll see. So these are all overloading concepts. Overloading. First one is operator overloading. Operator overloading. Next, method overloading. Constructor overloading. Overriding concept is this is. First one is method overriding. Next, constructor overriding. Method overriding, constructor overriding. So operator overloading, method overloading, constructor overloading. Method overriding, constructor overriding, like this only. Okay. So which one is support? We'll discuss now. Python will support operator overloading. Yes. Python do not support method overloading. Okay. Python do not support constructor overloading because method and constructor are almost same, but only constructor is called special method and method is normal method. So overloading of method and constructor not possible, sir. Why not possible also I will tell you. And operator overloading. Overloading of the operator is possible. That too with the help of magic methods or special methods are there. Every operator contains some magic methods or special methods. Using those methods only we can achieve that operator overloading concept. Otherwise not. So overriding we'll say. Method overriding, yes, happily it is possible, sir. Overriding of the method is possible. Constructor overriding, yes, constructor overriding also possible. Overriding, there is no issue. We can achieve easily overriding concept. But overloading is not possible. Method overloading, constructor overloading. But in other languages like Java, C#, .NET, overloading is possible. Mechanism of overloading is there. So operator overloading, yes, it's possible. First, we look into operator overload. When we can say an operator is overload, as I said that you can take plus is an operator, which is for perform addition of two numbers, and plus is an operator which is perform addition of two strings, and star is an operator which is perform multiplication of two numbers, and star is an operator which is perform a string value or any value can be repeated, can be displayed repeated number of times. So same operator will do multiple tasks for us. So that is overloading of the operator. But in Python programming, if you want to overload an operator, compulsory in your program, every operator should be replaced with magic methods. That is override with magic method. Replacement means override only. So every operator in Python is having magic method. In Python, every operator is having magic methods. Every operator is having magic methods. In Python, every operator is having magic method. What operator? Plus is the operator. It is having magic method like underscore underscore add underscore underscore like this. This is the magic method of plus. Minus is an operator. This is having underscore underscore sub underscore underscore. These are the predefined magic methods. So operators will work behind the scenes with magic methods only. Star means here multiply underscore underscore like this. Slash means here you can see this. Now underscore underscore division underscore underscore of this. And double star in the sense power. Yes, every operator you can take, no issues at all. All the operators are having magic method for sure. Suppose less than, you can take less than. Yeah, just wait, just wait. Yeah, now it's okay, Mister. Yeah, see every operator in Python, there is a magic method. Now you can see here in Python, every operator is having magic. So plus is operator, which is having magic method underscore underscore add underscore underscore. Minus is operator, that is sub. And less than means LE is there. Okay, LE. So sorry, LT, that is less than. If it is magic method is operator is less than or equal to, then underscore underscore less than or equal to LT, that is GT greater than or equal to. So every operator, you can take any operator, it's having magic method. So Python supports operator overloading with the help of magic methods only. Operator overloading possible with magic method. For example, let us consider this example. So normally we cannot able to overload an operator. Test 18 I'm taking. No? So in this case, just observe here. I have a class called some book. Book is a class. Here I'm creating one constructor. Now pages I'm taking. Now here self dot pages equals to pages. This is parameterized constructor, no sir? Yes. Self dot pages equals to page. B1 is what actually book object. Class is this. And when we create object to the class, who will execute? Constructor will execute. But this constructor is expecting what parameters? Pages. This parameter is input values, no? Yes. So 10 pages I'm passing. B2 is another object here. Book is what actually here you can see book. BOK book of 20 pages. So print B1 plus B2 like this. So two object references I'm adding here. B1, B2 here. B1 plus B2 like this. Now let's run this. Now you can see B1 plus B2. Type error, unsupported operand type for plus book and book here. Unsupported operand type book and book means what? Plus operator cannot support at this moment because two objects references we are adding. So if you want to overload this plus operator for adding two objects references values, compulsory this plus operator should be replaced or override with magic method. So magic method I'm including here underscore underscore add. We are doing plus operator. So plus means addition of two objects references. So add method, magic method, it is completely predefined. You can see this. It is having only two parameters. First one is self and next one is other. So here I'm returning here self dot pages plus other dot pages. I can say that self dot pages plus other dot pages. Now you can see df underscore underscore add self comma other return self.pages plus other.pages. So this is the case. So now this time internally, this plus operator can call or replace with add magic methods. This 10 values will go to here and 20 values will go to here. Then it return what actually two object references fields like 10 plus 20, 30. So with the help of magic methods only, we can able to do operator overloading. Without magic methods, we can't do operator overloading. Suppose even if I want to do multiplication of two objects references. So multiplication of two objects references means here star I'm taking compulsory. But here star is there, it's okay. Here star is there, okay. But magic method is wrong. This magic method is what actually? Multiply. So I'm using MUL multiplication. So this magic method is multiplication. So let's run this one. We got the output clearly. Now let's run this. Now magic method is working here. Multiplication 10 into 20, that is 200 pages are coming. Two references I'm going to multiply here. So every operator is associated internally with magic method. If you want to overload an operator for doing your task, compulsory in your program, magic method should be override. Means internally this plus operator or star operator can be replaced with this magic methods only. If we don't include magic methods, operator overloading is not support. Okay. So operator overloading is possible, but that too we have to include what? Magic methods. Otherwise not. And coming to the method overloading, not at all possible. Constructor overloading, not at all possible. Why not possible? Method overloading. Generally, when we can say a overload method, when we have multiple methods with same name with a different task, that is called overloading of method. For example, M1 is there. M1 is having one parameter A. Same method name M1 is there. M1 is having two parameters A. And same method M1 is there. M1 is having three parameters ABC. If you can able to work with this M1 with one parameter, this M1 with two parameters, this M1 with three parameters, then that time we can say Python supports method overloading, because this method is having already some work to do to deal with one parameter. Again, this M1 method to deal with two parameters. Again, this M1 method to deal with three parameters. So this method implementation is fine. It's having task M1, 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 A, AB, ABC like this one. Got my point? But in Python, it is not possible. Why not possible? I will tell you. Method overloading is not possible because in Python, when we have multiple methods with the same name, with different types of parameters, last method only will be considered in the program. Last method. Look at here. I'm creating one class called test. In this, I'm taking M1 method with no arguments, no parameters. No argument method it is. No argument method. M1. Again, same M1 I'm taking. Okay, one argument called A. Print here, one argument method. One argument method. Next, df M2, M1 I'm taking again. M1 I'm taking A comma B. Print two argument method. Two argument method. Two argument method. Two argument method. Class test M1, M1, M1. So M1 with no argument, M1 with one argument A, M1 with two argument. This is what I mean to say. If we can able to work with this function and this function and this function properly, then that time we can say Python support overloading of method. But here you can see when we create object to the class t equal to test and t dot m1. So we are calling this method. Obviously, when we call this method is don't have any arguments. So obviously you are hitting the request for this method access. What method? This method. No argument method. But no argument method will consider no. When we include three methods here with same name with different parameters or argument, in Python programming, last method only will be considered in the execution part. That's what overloading is not possible, I'm saying. Last method only will be considered. Now you can see when we try to run this, last method will expect, but we are trying to call this method without no arguments values. Now when we execute this, we will get error. Type error test class dot m1 missing two required positional arguments a b. Why you could not see the screen? Are you getting screen, all of you? Hello, are you getting screen? No, Mr. Akshay and Sweta, can you? Yeah. I don't know what happened from your side, but exactly because you left in the middle and again you joined. Yeah, good. Now coming to this, here you can see it's saying that the test.m1 missing two required positional arguments a and b. Means what is going to be happen here in this case? Now you can see t.m1 means m1 method, last method, what is there? This is only. This is expecting two arguments, but you are not passing. You are not passing means you are trying to execute this method. That's not possible. So in Python programming, when we include multiple methods with the same name, last method only will be considered. That's what overloading of method is not possible. If we can able to work with this method and this method and this method, then we can say overloading is possible. For example, one argument value pass t dot m1 of 10. Then wait is the related function m1 of 10 means this is second function. A is only one argument, it's okay. We are trying to call this function m1 function second function, but it's not possible again because last method only will be considered m1 method, which is having two argument values. M1 function missing one required positional argument, that is b. Okay, a is passing, yes, a value we are passing 10, b is expecting, so you have to pass b value also. So only last method will be considered, sir. So this is the problem in Python programming, why method overloading is not possible. Last method will be considered. In case if you don't have this method, last method is what? This one. This method is accepting what? One argument. So one argument you have to pass, that will work. All methods will not work. Similarly, constructor overloading also. Yes, constructor is also special method. It's almost same method only. Constructor overloading also not possible. So let's include instead of this M1 constructor, I'm taking init init underscore. So no argument constructor, I can select no argument constructor. And here also I'm taking constructor init, and here one argument constructor like this. So now when we create object to the class, who will execute? Constructor will execute. But how many constructors are there? Two constructors are there. If we can able to work with the two constructor well, then constructor overloading can support. But actually, last constructor only will execute. But last constructor expecting one argument, but you are not passing. So obviously, it will give error. Constructor missing one required positional argument, that is A. So when we supply the argument value, then last constructor will execute fine. That is one argument constructor like this. Okay. So constructor overloading is not possible. Method overloading is not possible. The reason why in Python programming, when we have multiple methods or multiple constructor in our programming, and what will happen? Last method only will be considered or last constructor only will be considered. That's the reason no overload of constructor, no overload of method. But operator overloading is possible, that too with the help of magic method. Overriding is possible. Method overriding, yes. Constructor overriding, yes. These two is possible. These two we'll discuss in tomorrow's session. Overriding, how it is possible, we'll discuss now.